Welcome to Embedded. I'm Alicia White. My co-host is Christopher White. Just about every embedded system project starts with blinking lights. But what if that's the end goal? Aren't there some interesting things there? This week, Ben Hencke is in studio with us to talk about light controllers, Tindie, and learning hardware as a software engineer.
Hi, Ben. Welcome to the fine studio.
Hi, thank you for having me.
It took no time at all to get this set up. It's all ready for guests to come in and just hit the ground running.
Could you tell us a bit about yourself?
I'm a tinkerer at heart. I've always been really interested in gadgets and making things and inventing things and taking things apart and, figuring out how they work and sometimes putting them back together properly and sometimes not, sometimes just leaving them in a pile of pieces. But really just curious about how all that stuff works. Career-wise, I've been mostly doing software, but early 2016, I kind of just jumped in headfirst into hardware. Sort of pursued my hobby as like a potential, career path. So trying to follow the dream of, can somebody just like make a bunch of stuff in their garage and, tinker around with things and, if not, become, the next Tesla or whatever, but like at least, make a living selling kits or parts or things like that.
And so you're on Tindie now?
Yeah.
Okay. What's your stage name? Wow, that's not the right word. What's your store name?
My store name is ElectroMage.
ElectroMage.
Yeah.
Okay. So I'm going to ask you some about Tindie, but mostly about what you have there and some of your other projects. Our outline this week is called Ben and Blinking Lights, just so that those of you listening know where I'm headed. But first we have to do lightning round. I'm not even going to explain that.
Yeah, have to do it. Has to be done.
Has to be done.
This is my favorite part.
Christopher, you first.
Do you like to complete one project or start a dozen?
I definitely like to start a dozen projects, maybe more.
How many of those do you complete?
1 out of a dozen.
Okay.
It's good to know yourself.
Yeah.
Beach or mountains?
Mountains.
How many bits?
4 or 64.
4?
Yeah.
Okay.
My first foray into microcontrollers was this Radio Shack kit, and it was like this little 4-bit microcontroller with like a hex LED and like a couple of LEDs, and you'd like punch in single-digit opcodes, and yeah, it was fun.
Open Source Hardware Summit or Hackaday SuperCon?
Ooh, that's tough. Both? Is that valid?
Both? All right.
Favorite wavelength?
950 nanometers.
Technical tip everyone should know.
Figure out how to configure your IDE or editor, whatever you're using, to let you look up the source code for things. So if you're using an RTOS or you're just using a library, jump into all these functions and like see how they're written. You can learn crazy amounts of stuff that way.
Reading code miraculously does often make me a better programmer. Okay, I think that's enough lightning round unless you want another one, Christopher.
Oh, yeah, I can be done. Just seemed very cursory.
It was lightning.
Oh, is that how it's supposed to go?
That was very quick.
You went to the Open Source Hardware Summit recently. What was that like?
I did. It was awesome. It was an amazing experience. So I've gone 2 years in a row now and just met some of the most amazing people ever, and seen some pretty incredible projects. Stuff like bringing medical devices to to countries where access to this kind of technology is difficult, or even in remote areas. Maybe where you just can't get supplies in, and just bringing sort of open source projects and technology to those people to kind of help them build things or survive catastrophes and things like that. But beyond that, just meeting a bunch of amazing people and just talking about fun stuff. I mean, it's really cool to just be able to walk up to anybody in this organization and just like talk about cool, fun, geeky hardware and software projects.
Yes, I haven't been, but I've heard it is a lot like SuperCon in that there are just so many people and everyone you talk to has something cool they're working on. How do you decide what conferences to go to? And are there others? I mean, there are those two I know you go to, but are there others?
I mean, in the software part of my career, I've gone to a bunch of different conferences. I try to be pretty judicious about which I end up going to. It's kind of funny, but like almost always, the talks are sort of the last on the list of things that are interesting at the end of the conferences. So it might be like, hey, we're doing this conference and there's all these great talks and you get all jazzed up about it, but then you end up meeting like really cool people. Or, when I was going to DEF CON, like, I'd just spend like the whole time in like the hardware hacking village and just messing around hacking badges and stuff like that. And so these days it's those are the only two I've been to recently. In the software career, there's all kinds of fun stuff. DEF CON was definitely the best, sort of mix of software and hardware. That was pretty fun.
And at the Open Source Hardware Summit, did you meet John Leeman? He's the Don't Panic Geocast guy.
Yeah, I did.
Okay. He did a really good summary on their show. So I was going to ask you more about like what talks you went to and who else you met, but I think I'm going to skip some of that and say just go listen to John's report on the Open Source Hardware Summit. I have a really hard time saying that, but yes. That's the Don't Panic Geocast with John Leeman and Shannon Doolin. Okay. One of the other events you went to recently.
So is that
going back?
He's the guy that did like the seismic kind of recording tests and like record gigabytes of data in milliseconds kind of thing?
Yeah.
Yeah, okay. Yes. Then yes. Same guy.
That's fine. You can just say yes. It's okay.
Well, I didn't know if I remembered the right person because I'm terrible with names. I can remember somebody based on their project a lot better than I can remember their name.
So much so. Well, that actually does lead into what I was going to say, and that's hats and hacks. You came to our party last January.
Yeah.
And as far as things, people's names that I don't remember, but I remember what hat they wore or what hack they brought, yes. And you won the hack contest part of it with a hat. Could you describe that?
Yeah, so it was a Wi-Fi enabled hat, and you could connect to right. And what could you possibly need Wi-Fi on a hat for? Well, of course, so that you could log into this thing and change the lights because it had a bunch of lights going around the brim. So you could actually log in and change it. So instead of just like selecting some patterns, it was all the math. So it's basically a web page with a bunch of like expressions on it. You could go in there and like tweak numbers and type in stuff and change the pattern of the LEDs all in real time.
Okay, tell me about the math parts and how I get good patterns from typing in cosine t or whatever I needed to type in.
Yeah. So it helps out. It helps to sort of start in like an HSV kind of color space, where you have, hue is if you imagine like a circle or like a clock, but instead of like, 12, it's like, 0. Right. And it goes around through the circle from like 0 to, like half down at the bottom to back up to 0 up at the top. It's a terrible explanation.
It's difficult to describe color spaces in audio. So
you basically have, a color around this rainbow that loops around in a wheel. And that makes it really easy to use, to use things to just sort of like change color. So you could have an infinitely incrementing number and it would just basically be shifting color, to the end of time. Because you basically take the mod 1 of that, you get, this fractional floating point remainder bit and feed that into color space and you get a color. So if you want it to, shift around or change over time, you can, offset it based on time. You can, take the sort of the pixel index, some fraction and use that. You can then feed time through a sine wave, and then you basically get this thing that shifts back and forth. And then you can take a bunch of sine waves and kind of overlap them, and create fun interference patterns, and just end up with interesting blinking LEDs.
And so, if I did a square wave, a sawtooth pattern, mm-hmm. then when it was at the high point, it would be red. But as it went through the whole ramp, it would go down and it would go red, orange, yellow, blah, 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 until it got down to violet. And then it would go back up and and cycle through again. But if I did that on the value of the HSV, then I might have like green all the time, but it would be like a snoring pattern. A sawtooth would be more like a bright up, and then it goes dark, and then bright up.
Yeah.
And then but this whole math thing is kind of a little language.
Yeah, it is.
Where did it come from?
So it started off as a hack, even before it was a hat. It started off as a hack, and it was just like, can I reduce the sort of the iteration cycle of like programming LEDs? I've done a bunch of LED stuff over the years for Burning Man projects or just little tinkering kind of things. And, always it's the same kind of thing. It's the same kind of thing that, I imagine embedded engineers have is if you want to try something, you got to, make your changes, compile it, wait for the compiler to finish. It dumps out some hex file or whatever. You run it through your programmer connects in, uploads it, resets the thing. It boots back up again, and you can test your new code. So I was trying to see, like, is there a way to kind of shortcut this? Is there a way to, reduce the iteration cycle on this? And so I found an expression parser, and it basically just takes like a mathematical expression, in a C-like syntax, and then gives you, an abstract syntax tree that, you can then do things with. And so, okay, well, what do I do with this abstract syntax tree? Well, basically, I end up turning it into a stack machine. So I unroll this tree depth first into a series of operations that push things onto a stack. So if you wanted to call HSV with the values 1, 2, 3, you'd push 1, 2, and 3, and then push the operation for calling HSV. And then HSV would, pop those off the stack and consume them and potentially return a value and so on and so forth. So I did all that where you could, type in this expression, it would get parsed, compiled into, basically a set of these instructions, and then that was fed down into the chip, and then a small, virtual machine. It's really just simple. It's just going through, the sequence of operations. And then, sometimes it's, calling out to like, oh, I need to add these two numbers, or I need to multiply them, and so on.
So is all of that running on the micro?
Yeah. The parser was still JavaScript web-based. So that's all, still browser. I'm not doing any of the parsing on the actual microcontroller.
Okay.
But what does the microcontroller receive from the Java page?
So it receives something that sort of looks like an assembly language. It's a bunch of, mnemonics for, operations that need to happen. So if you need to add two numbers, I send on a plus. And then, I tell it that, you need to consume two arguments. And then so on the microcontroller, I parse all this stuff out into, more efficient bytecode, to run in memory. And then just basically run through the list of operations.
And what's the microcontroller?
It's an ESP8266.
Those are the $4 Wi-Fi controllers that are so ubiquitous and are not at all based on ARM Cortex anything. Yeah,
they're pretty amazing. Like the processor that they put into these things is very impressive. I mean, this thing, it can run at 80 or 160 megahertz, has crazy amounts of RAM and like 4 megabytes of flash, and in a pretty cheap module. I mean, it's a game changer.
It really is, but it's getting older now.
It is.
And there are new ones out.
Yeah, so they have the ESP32, which is its big brother. And it's got Bluetooth in addition to Wi-Fi and all kinds of other cool stuff. Heaps more RAM, a little bit faster clock, 2 cores actually. So they have 1 core dedicated for all the, Wi-Fi management type stuff, and then one for you to, just run whatever you want to run on it. And those are interesting, but they're also a little bit more expensive, a little bit bigger. So I think there's still room for the ESP8266 just being a cheaper, smaller module.
Okay, so you have lights as well. What kind of lights were you using for this hat?
Yeah, so I started off, when it was in the hack phase with NeoPixels, and I've been using those for, a really long time, the WS2812, 2811s. But I haven't had great luck with them. Like, they always glitch out or get flaky, and
the blue glitch, which can only be fixed with the appropriate capacitor. The appropriate capacitor is always not the one you put on.
Yeah, and sometimes it's I don't know, it's like the whatever die manufacturing process that goes into these things, they delaminate themselves, or contamination gets in there and messes it up. And sometimes you just have to take, the whole, LED off, or just cut the strip and, rewire it. So around that same time, I saw, people started to mention the DotStar APA 102s and started to see those pick up a little bit more traction. And I thought, hey, that's pretty cool. Let me check it out. Well, I got some and I was just blown away. I mean, these are really cool LEDs. So they're pretty similar in terms of, they have, three channel RGB 0 to 255 kind of values. But they also have another channel for overall global brightness, and they operate at a faster PWM refresh rate. So if you've ever seen, NeoPixels, they're not really great for like persistence of vision type effects, and even if they're just stationary, they kind of blink if you're looking around, or if you
they're just not fast enough.
Yeah. So these are awesome. And I ended up exploring that global brightness. It's additional 5 bits on top, so it's basically like multiplied with the brightness of the channel, and it's not per channel, so it's the overall brightness for all RGB. And you can do some pretty amazing stuff with that. So one of the things is if you're using like a NeoPixel and you're trying to get something that's not just blindingly bright and blinky, but it's something that's a little bit more subtle, it just really doesn't have the resolution to cut it at lower light levels. So if you look at like the brightness difference between a 1 and a 2 is just staggering. And between a 0 and a 1, it's like clearly on or off. Like there's no, fade to nothingness kind of levels. And so you can actually do that with these APA 102s. And I ended up figuring out, how to basically take an HSV function and take that brightness level and then convert that back in and figure out how much I need on the RGB side and how much can I feed into that global brightness. And so you get just these incredibly smooth transitions, and it'll go down to like where you can't even tell that it's on, and you have to like look at it really, really close and you can kind of tell. So it's pretty amazing.
I'm surprised because 5 bits doesn't seem like enough to make a smooth transition. Is it because it's multiplying against the other one, so you can kind of
it's 5
expand the space?
Plus 3/8. No, is it how many colors how many bits do you get to set the LED? Is it 8 bits per LED, or is it 8 times 3?
So you have 5 plus 8, basically.
Okay. Yeah.
But it's not exactly just 5 plus 8, because you end up getting more of the different variations at lower brightness levels, because they're effectively multiplied together.
Okay, that makes sense. But it does make it a little trickier to say, to take an input and say, this is what I want, and figure out what those 5 bits should be, because there's going to be spaces where you need to know, oh, this is one of those dangerous areas where I want to use the global thing to get me more range, right?
Yeah, exactly.
Okay.
I mean, ideally, you just want to say, hey, I have this brightness number, make it so, and figure it out. And don't, set the global brightness and dim down green, because green's bright. And so, I mean, I figured out how to smush all that into this HSV function. And you basically get it for free. You don't have to think about it.
Cool. Okay, so one of the things I have learned about the LEDs like this is that they require power handling. I mean, they need more oomph. They draw more current than like if you just have 2 or 3 LEDs out there. You can't drive their power from your processing board.
Well, yeah, I guess it depends on what you're powering your processor with. A LiPo 4.2 battery. Yeah, I mean, those can put out quite a bit of juice.
I've got some in there that'll melt the house.
Your aircraft batteries. It was a hat. And you didn't have a backpack, so you had to put some power on there. Yeah, I mean, they do take a surprising amount of juice. I mean, it adds up very quickly. So, I mean, each of them is, imagine 20 milliamps per element. And you're like, okay, well, it's 20 milliamps. It's nothing, right? Yeah, it's trivial. Yeah, but then you have a couple hundred of them, and all of a sudden, things are melting, and your hat's catching on fire.
Actually, so the APA 102s are a little bit better than the WS2811s in this regard. So if you look at the strips, the WS2811s actually have little tiny capacitors. They have a bypass capacitor basically like on every single chip all the way down the line. And the APA 102s don't need that. And the reason for that is that the signal and timing conditions for those WS2811s are like super, super critical. And if they get any kind of noise on the power supply, they can end up freaking out and getting the wrong signal, and you get weird flickering effects and all that kind of not so fun stuff. The APA 102s are basically a SPI, right? So you have a clock and a data. And so the integrity of that signal is good enough that, at least on all the strips that I've seen, they don't have additional capacitors on there.
And I've used SPI with the WS2812s, the NeoPixels, but it's not like I'm using it as SPI. I'm like using the SPI port to trick it into talking to these NeoPixels. With the DotStars, the APA 102s, it's really SPI. It's really data and clock. It's not some weird, specially timed driver needing bizarreness.
Yeah, exactly. And people have done a lot of interesting tricks. Charles Lohr has the I2S driver on the ESP8266, which is pretty awesome. So basically fill up memory with a bit sequence that this thing uses this I2S driver to just basically, spew out a bit stream that ends up fooling it to think that it's in the right protocol. It's amazing stuff.
I2S is usually used for audio codecs, right? So
yeah.
Pretty high speed. So it just replays that whole thing over the thing. And
yep. That's
a great idea.
Yeah, I mean, and you can clock the I2S driver on those ESP8266s to something ridiculous, like 40 megahertz or something crazy. I mean, way beyond what you need for audio. You can really abuse that peripheral.
And we had Charles Lohr on the show talking mostly about ColorChord, if I remember right. And he had an ESP8266, and he was controlling LEDs. But he was controlling them live. So if he was playing music, he wanted the LEDs to go with the music that he was playing at that time. But with your hat, I would log into it and set it up for a pattern and then go away, and it would continue that pattern forever. It didn't need any live input. Is that a fair assessment of how they're different?
Yeah. And so, I mean, my understanding, ColorChord is all audio driven, and it's really cool. I mean,
it's very pretty.
Yeah, it's pretty cool stuff. And he's doing some pretty amazing audio analysis on the ESP chip, using its ADC and all that kind of fun stuff, as far as I can tell. It's just really, really cool stuff. On the controller that I've got, right now it's all based on time. So time is your only, variable really. And then you just feed that in through a whole bunch of math. So it's good for, non-interactive patterns. That said, it does have a WebSocket protocol, so you can actually, connect to this thing through a Raspberry Pi or something like that and feed it in variables. So you could use it to, set variables in real time if you had like an audio processing, engine or something on a Raspberry Pi or some other computer, or even another ESP8266.
I mean, I like both, because sometimes I want the lights to go with what I'm doing, and sometimes I want to be able to set up a lamp in the living room and not have it need constant interference from me. I just want it to do the thing it was supposed to do. Okay, so this was your hat, and then a few months later, you sent me a widget, and you said this was it. You named it Pixelblaze. Mm-hmm. And you gave me one, and I think I blew it up immediately because that's how I roll. But then you gave me another and explained it to me and wrote a nice getting started guide or an idiot's guide to not blowing up my board, I think was maybe what you were thinking it should be called. But you gave me the board and some LEDs, and then you said, I'm thinking about putting this on Tindie. Why? I mean, selling hardware is hard. Why would you do this? I understand building these things. But why does anybody do this?
Yeah. That's a great question. So, I mean, I want to build things and hopefully make a living doing that. Otherwise, I'm going to have to go back to, boring old dry software 9 to 5. So, I mean, this was something this was a hack that I thought was pretty interesting and kind of unique. And I thought, maybe this would be useful for other people. So can I polish this up? Can I put it out there? Maybe sell a couple units, but more just to get the experience. Like, what does it take to do that? If I'm going to do this process for something that's, bigger or more complicated, try it first. Try it on something.
That's a really simple. Good point. Yeah. Go through the whole pipeline and process with something that's easier to do.
Yeah.
Learn the hard part of the business side, or at least the production side, without a massively complex product.
Yeah, and all the things. I mean, there's so many things to keep track of and to learn and to figure out. And on the technical side, I mean, those are all the fun challenges. But then you have stuff like, okay, well, how do I ship this thing? So, like, one of my first orders was to somebody in Spain. And I'm like, okay, how do I ship a package internationally?
That's always the first problem.
Do you ship to... Yeah.
Yeah. And, having no idea what to charge for these, I put the price at like, $40 with free shipping. And I figured, I'll just eat whatever the cost was. Well, it turns out that shipping can be quite expensive. And it was a learning process. I had to figure it out. And another guy I ended up shipping, and, I was shipping by United States Postal Service, and they have like these rules, like if it's more than 3/4 of an inch thick, or if it's rigid, and all this kinds of stuff, then, you need to use this, ship it as a package. Otherwise you can ship it as just a regular envelope. I was thinking, okay, well, this is a little teeny board. It's not, it's not like, you can't fold, the non-board parts of the package. I can't imagine it getting stuck in some kind of autoloader or something like that. It's definitely not more than 3/4 of an inch thick. So I, put it in the mail, and I get this email from this guy that's like, understandably very upset because they actually charged him the additional postage.
Oh.
Yeah.
Oh.
Yeah. And I was able to work it out with that guy, but I was like, oh, that's a learning experience, and that's not something I want to give, people that buy my stuff. I want them to have a great experience on that, to say, oh, this is really cool. I got this thing. It's really, really fun. Not like, oh man, this guy said it was free shipping and I got hosed on, extra shipping charges and all that kind of stuff. So, shipping was a whole learning experience. Then there's the whole like marketing side of things. How do I tell people about this? Right. So Tindie is great. Cause you can put it up in the store and people do browse. But it's, it's not enough to like drive everything. So you have to do, some marketing beyond that, and just learning how to even do that. And I don't like to, I don't like the extra spammy stuff, or, if I'm following somebody on Twitter and they just start not posting anything interesting, and it's just continuous spam. I was like, I don't want to follow that guy, right? I don't want to be that guy. I want to post interesting stuff. But at the same time, like, this is how I can generate interest and even just knowledge about this thing's existence. And so just trying to figure out, where I can do this and how to do that in a way that I'm comfortable with, but also that is interesting to people.
HP, when I first worked there in the 90s, had this reputation of being very bad at marketing because they promoted their engineers to marketing positions. And so there was this phrase that if HP sold sushi, they would call it cold dead fish. And as an engineer, I'm like, yeah, of course, that is how I market. I made this thing. Here are all the problems with it. And
here's why it might not work for you.
Yeah, it's
here's why you shouldn't buy this. I'm really embarrassed to be selling this. Please don't buy it.
And yet people, and as an engineer, I don't mind buying that way either, because I understand the discrepancy between another engineer telling me what they made and how it doesn't work. I'm used to that. But most people would rather have sushi be called yummy deliciousness instead of cold dead fish. Or maybe we should just call it sushi. And so I understand.
Which means cold dead fish.
I understand the difficulty quite well. And my own exploration into marketing is entirely about this podcast, which we are terrible at marketing. So what have you learned? Where did you go? I mean, Twitter isn't it. I know because people keep telling me I should market someplace other than Twitter.
It definitely helps. And I think it's really about, connecting with people that are interested in this kind of stuff and trying to figure out where they are and where they hang out. And it's kind of weird because like I am one of those people. Like I built this for me. Like I am my target audience. But I just messed around with Arduinos and stuff, right? So I had like a bunch of Arduinos, or if I needed to, I'd like build a board and like put a PIC in it or something like that. Or eventually an ESP8266. So I was just, I was really about do it yourself kind of thing. But for me, that was sort of like the thing that was the most interesting. It wasn't necessarily the end product. So I started off thinking like, well, who's interested in having, the end result, cool looking LEDs, as opposed to like figuring out how to make a board and, like program a bunch of stuff and all that kind of fun stuff, right?
Who wants the output of my work instead of doing all the fun stuff like I did?
And it got me to thinking like, well, okay, artists, right? People that make interesting, like physical artistry.
Installations.
Yeah, exactly. And maybe not, like the big fancy installations, because obviously those, you need, a lot of thought and design and almost the technology is secondary to, the desired effect on those sort of things. But, local artists, I mean, Santa Cruz has a huge artist community. So I've got a lot of friends I've reached out to, hey, can we incorporate this into some of your artwork? And that was actually, that was a great start in figuring out, how will this thing work? And I tried that market first. And, it was actually really cool. So my buddy does these amazing laser cut wood mandalas and other things. And he was making this, he was commissioned to make this gorgeous Tesla portrait of Nikola Tesla, and just amazing multi-layer. I mean, I can't even describe it accurately. And so we ended up putting one of my controllers in there, but taking away all the programming aspect and just reducing it down to math wasn't enough. Like for that target market, the math stuff was still too much.
Oh yeah, because most artists also get degrees in math. And
right. Of course.
Signal processing.
I mean, who wouldn't?
Trigonometry.
And interference patterns. I mean, yeah, totally. You want two sines and a cosine in order to build this pattern I want. Yeah. I found your math interface confusing until you did more of a write-up on it. And then once I realized I could copy some of your canned ones and change them, that helped. But okay, so yeah, you figured out that the math part was not optimal for your target market. Yeah,
so that wasn't probably the best fit. So instead of pursuing that, and going deeper into there, and again, this sort of started out like, and this is the opposite way that you should build things. You don't build a product and then figure out if you have a market for it. You figure out the market and then design your product around the needs of that market. But of course, this is a hack. This is for me.
So. Thing. Yeah.
So I'm coming at it from the other direction. So I'm just trying to see where this really fits. And I've had a lot more interest with the kind of people that are a little bit closer to me as opposed to, necessarily, artists. It's people that want to do cool stuff with LEDs.
Okay.
And so I've been tailoring it more and more to that.
All right. And do you see a big future for this product, or are you already planning your next one?
Yeah, I mean, I'm still working on the feature list. I mean, it's funny, even like, okay, well, when you started the show, well, the first thing you do when you start a microcontroller, right? You get an Arduino or whatever, you run the blink sketch and you're blinking an LED and I never really stopped with that. You just kept blinking LEDs. More LEDs, more complicated blinks, interesting, even infrared stuff. I mean, it's all just blinking LEDs at the end of the day. Sorry, I forget. I totally lost track.
What's next?
All right. What am I doing next? So even just for blinking an LED, like the amount of different features and product enhancements that could go into this thing is pretty crazy. So I've tossed around ideas for segment mappers, right? So that's a pretty common feature request where, okay, so I've got the strip of LEDs, but I want this half or these 20 to do something different than the rest of them.
Oh, right.
And things like that. And so you can do that in math, but it's kind of a hassle.
What about syncing multiple?
Exactly. And that was the other highly requested feature was, okay, I want to use this in, in like a costume or something. And I want, one in my left boot, one in my right boot, and maybe a belt or something like that. And I don't want them to just do random unsynchronized stuff. I want them to all sort of like line up. Maybe control all of them with, one interface. So I don't have to like log into the Wi-Fi of each of these three things individually. But if I do put them on the same pattern, like it would be really cool if they, at least shared a time base. So there's that.
That doesn't seem easy.
It's harder than it should be.
I mean, because they're each individual microcontrollers,
mm-hmm.
and they don't share a common clock.
Right.
So you have to have a start signal, which needs to get to them all at the same time. And 802.11.
Yeah, you just run an NTP server on one of them.
Yeah, exactly.
And it all works itself out.
Yes. All right, that's a solution.
Yeah. And they actually have NTP libraries if there is an NTP server somewhere else, but I haven't seen any NTP servers for these things.
Yeah, that's the trick. Client is one thing, server is something else.
An NTP protocol has got, it does all kinds of other things that aren't necessarily, super critical. So I ended up looking at the, specs for NTP and re-implementing some of that protocol, especially the back and forth, and time window calculation, and got pretty close. But, this hack that started out, running in the Arduino framework is still, all executing in this main loop. And so the main loop is doing all these things. It's calling out to the web server. It's calling out to the, pattern engine. It's calling out to the, the WebSocket thing, and trying to do some time sensitive UDP all in the middle of that, doesn't really work too well.
I'm surprised it's working as well as it is.
Yeah. So, I mean, the next thing to go from there is maybe look at, doing some async stuff, right? So, there's libraries out there that will, call, some handler in an interrupt. So you're not waiting for, whatever is going on in the main loop to finish what it's doing and adding, tens of milliseconds to your time sensitive thing.
And you don't want to move away from Arduino because you don't want your customers to have to do something more complicated, right?
Well, actually, so the customers don't have to touch any actual traditional IDE or development environment at all, and that's part of the draw. It's literally you just fire up a web browser and you're good to go. But yeah, so I mean, it started off in that framework, and I've been looking at what will it take to get away from that. So you can take the expressive, I forget what they call it, but they have like an SDK, and just go from there. And write or find a web server that's open source, or write or find a WebSocket server, and something that helps you set up Wi-Fi and all that kind of stuff. So there's all these libraries that made it a lot easier to sort of get started, but they're not, I would say, professional enough to really have it be considered like completely dialed in, and it's sort of a dead end. For a lot of those things. So it's like, okay, do I start from scratch or do I just, live with the limitations that I have right now and, keep going? So, and that's the same kind of challenge that, that I imagine all projects face, at some level.
Mm-hmm.
Yeah. Do I pay the technical debt or declare bankruptcy and go on?
But it does sound like this product has a lot of headroom. I mean, it's a very powerful chip. You have lots of space. There's lots you can do with it without changing anything except software.
Yeah.
So it costs about $40.
Yeah, and I've actually in the process of figuring out how to manufacture these things at home, I've gotten better at it. So It used to take me a lot of time to put together one of these boards. So a bunch of little surface mount things, an ESP chip. And a fun excursion into figuring out how to get panelized PCBs that weren't panelized. So I had this little tiny PCB and this stencil that's like, an 8x10, size stencil or whatever, and it's got just one board in it. So I'm doing them one at a time. But I've got, I've now upgraded to this like pneumatic thing. So it's basically like a little air pump and a little tiny, syringe thing with a little needle that I can pick up these little 602 resistors, a lot faster than tweezers.
And assembling these yourself is, do you know other people can assemble things for you?
I do. I've heard, I've heard of these places.
I mean, I didn't have to build my Mac by myself.
But you're enjoying the building part.
Yeah. And I haven't had the volume. So
that's the thing. This is a curve, right?
Yeah, you have to have the volume.
It has to be cost effective.
Yeah. Before I jump in and, build like a couple hundred of these things, I want to make sure that I'm going to be able to sell them. Otherwise, I'm going to have more fun gadgets than I can possibly figure out what to do with. So I've actually dropped the price a little bit. So they're $34, I think, right now, or like $29 if you buy 3 or more. And I do have a code for your listeners.
Oh, right, a coupon.
Yeah. So if you go to Tindie and you look up ElectroMage and you purchase some of these and you put in the code EmbeddedFM, you get 25% off.
Wow.
Yeah.
Thank you.
I'm going to buy them all.
Okay.
He doesn't care.
I can make
then
more.
He gets to make more. And I do feel like I should say that if you decide to assemble things, you should talk to Bob Cogshaw over at Small Batch Assembly because he's giving out embedded FM discounts too. Yes, I actually often.
Bob, if you're listening, I have a draft email that I'm working on right now. And I'm just trying to figure out, okay, well, how do I source all the parts for these things? So I did a little bit of digging, and I can get these ESP8266 modules that are usually, they come to me in like these little like anti-static bags, and that's great. But I imagine you can't feed a handful of anti-static bags into a machine and have it assemble things.
Not yet.
Not yet. So getting, some sort of like tape or reel of these things, figuring out how to source all this stuff. And then of course, the transistor that I use for the level shifting is like out of stock everywhere. So I have to figure out an equivalent transistor, and I'm like reading data sheets, and that's really fun. Figuring out, gate charge and
but this is
a second rise time.
This is a huge skill set. I mean, this is something that once you've done this and you've gone through the process and you learn some of these gotchas, I mean, doing this anywhere else, you're going to have a leg up on a lot of people, right? Because that's the whole production / manufacturing / electrical engineering thing.
Yeah. And it's fascinating. It's exciting. It's fun.
Sourcing is a skill. I mean, all of these things, knowing where to go, how to KiCad up a board.
And for small companies, this is not something like you were suggesting that you outsource a lot. This is something you have to, it's on you to figure out, okay, I need these parts and this one's difficult to get. So can I get 2 sources and that kind of thing? Can I put this into a kit that I can send to somebody to? So yeah, this is a great learning experience.
So the ESP8266 boards on their own are like $4. Yeah. You're like charging like 40.
Mm-hmm.
So you're
so what's the deal with that?
30.
So
why is it so expensive?
Let me explain capitalism.
And I mean, I would love to sell them for, exactly what I paid for them, but then I wouldn't be making any money. And it's really to figure out the economics behind it. And so that's funny. So I ended up like looking into this thing, like how do you even price a board? How do you price this thing? Well, can I just take whatever it'll cost to make and then just add $1? Well, probably not. If you're spending, so you got the ESP chip, you've got the board, you've got all these like transistors. There's some like some through-hole stuff.
Just the whole bill of materials.
Yeah. So you got all these things, and then you got to figure out, okay, well, how much is it going to cost me to like package and ship these things and all that kind of fun stuff. And there's a formula, like what if you want to ever have a reseller for these things, right? And that'd be pretty cool. Like, and I'm not thinking that these things are going to be the most popular thing, that they're going to be carried, in whatever replaces Radio Shack, but
Adafruit.
Yeah, exactly.
But yeah, I mean, it would be kind of
that
cool.
Would be cool
if they were on Adafruit. And Adafruit has carried some others, like Fade Candy.
Yeah.
And SparkFun carries some things like this. So
yeah,
you can start, once you have a sales record.
Yeah.
And a fulfillment record.
Yeah.
You can start looking at them.
Yeah, exactly. And the price is part of that experiment, to try to figure out, what would I have to sell these things at, to be making a little bit of money, even if I was in like a reseller type situation. And then, try to adjust for there. So like once I can get my manufacturing cost down and I'm not spending all day building like a couple of boards.
What's the thing? Because your time is valued at, every hour you spend on it is your hourly rate.
Yeah,
right?
exactly.
So if it takes you an hour to build 2 boards, that's pretty expensive. That's the tricky bit is incorporating your labor into it beyond just parts and that sort of thing.
Yeah. Yeah, exactly.
But going back to my question, it wasn't just a how do you price it? It was a what does it have in addition to the base board?
What's on the board? What do you get? So I tried to keep it as small as possible. So it's basically
he's showing you with his hands, by the way.
Yeah. It's this many inches.
He's showing his hands. It is a small square, less than 2 inches, but greater than half an inch on each side. Sorry.
I forget, but I think it's something like 40 millimeters by 25 millimeters or something like that. If you don't count the ESP antenna, and if you do, it's whatever that is. So it's the idea is it's pretty small, that you could incorporate it into wearables. Obviously, I'm still using ESP, 12 module, so it's, it's still at least postage stamp size. I added in screw terminals because in pretty much all the projects that I've ended up working on, I've either, used like little, like the 10th inch spaced header pins or, soldered things in, and then you need to take the thing out, and then, it's just a hassle. So I ended up going with screw terminals so that you could install this thing and remove it without any kind of soldering at all. And you could just, go from some bare wires that you've got coming out of your piece or whatever. So there's a screw terminal to connect to the strip. There's a micro USB connector for power. And then on the right-hand side, there's a header where you can actually connect a button and cycle through patterns or put it back into Wi-Fi setup mode.
All right. And the USB is primarily power, but that's also how you program it.
USB is just power.
Okay.
So I actually program it on the header that's on the right-hand side. So it's got, all the things that you need to flash the ESP. So the serial port, power, ground, GP0 and reset, so that you can hold that low and put it into programming mode.
Do you bring out any of the other ESP stuff, signals, or for prototyping, or is it just
adding an accelerometer?
Purpose build?
Yeah. So today it's just what's on the header. So obviously you can use GP0 for the button, so that's repurposed. But so far none of the other pins on the version 1 board. But
that's a size versus extra headers, choice. Yeah.
But today actually I sent to OSHPark, favorite board prototyping place ever. Those guys are awesome. I sent out a new version. So I was able to move things around a little bit, and I've exposed the ADC, and what I want to do there is add in a software. So like in your expression, you could use whatever's going on in the ADC. I think that would be pretty cool. You could at least do like a VU meter or something, things like that.
Yeah.
And then on the backside, I'm not adding additional, like through holes, but I've exposed a bunch of pads for all the other pins. So all the IO on the new version are exposed.
Cool. I was specifically thinking about audio. When I thought of that question, it's like, what if I want to do something with a signal, even if it's a low rate signal, you can do some really cool stuff.
Yeah, Christopher today, after doing our own things for a couple of hours, he returned to the kitchen and he said, "I made a project." It was kind of cool.
I just put a kit together.
So it's still fun.
Doesn't work right.
It will. All right. So you're selling these on Tindie. You're learning a lot about building a small kit company, and you have not told very many people about one of the coolest things you built with this. I mean, the hat is cool. I give you that. Mm-hmm. But when I saw the light you built for your daughter, I was just like, okay, to heck with selling the board. Just sell kits for that. It was awesome. Could you describe it?
Okay. Well, there's an idea. Yeah. So this is it's basically like a design that I based off of a tulip, and it's all like laser cut. So it's a bunch of acrylic. So I took an acrylic sheet and I kind of drew like an outline of a tulip petal, whatever I thought what a tulip looked like. I had to Google it, right? And fortunately there's, like little paper mache patterns or whatever for tulip, petals, and took that. And then, I was like, okay, well, this is cool. So I fired up OpenSCAD and they have this this was a fun detour. Learned all about L system fractals. So that was fun. And made a little like fractal tree pattern thing that I could etch onto the petals. So instead of just being like a plain acrylic sheet or whatever, it's got fun fractals on it. Laser cut 2 of those, and then made a vise, some wood discs, held that together, and then got a heat gun and heated up these petals. And then when the acrylic got malleable, I was able to kind of fold them in, so it's more of a flower, 3-dimensional flower structure. Okay, so now I've got this this basically donut thing, and 3D printed a bracket that basically let me stuff these LEDs in facing outwards so that they'd shine into the circle donut edge of the acrylic, and then as it went through the curve of the bent acrylic, it's bouncing around until it hits the edges or the laser cut etched parts. So I've got that. I've got photos of that up on. I don't have it on my website. I should put it on my website.
No, you don't have it on your website.
Yeah.
And you don't have it on your Tindie store, where you could say you could build things like this.
Yeah. You got 3 days.
Yeah.
Okay.
By Wednesday, maybe Thursday.
Yeah. And maybe that's pretty easy because I could just upload the patterns if people have access to a makerspace.
Well, that was the thing, is that you listed a number of things there. You have the laser cutter. Mm-hmm. You have to etch it, which is probably the laser cutter.
Yeah.
Unless you have a water jet, in which case you also need a laser cutter. And then you need to be able to melt it safely. Although if you didn't want to use that pattern, there's the malleable plastic that you can heat up and it gets soft. And for as long as it's warm, you can squish it around. Mm-hmm. That doesn't have the clear sides, so it would glow much differently, but it might still work.
Yeah. And I think you could probably take the acrylic and even just put it into your oven, put it on I forget where the deformation
into
temperature.
Your reflow oven.
Don't try this at home.
Yeah.
Yeah. Don't use your
bake some cookies too.
Cooking oven.
One could maybe do this. But we shouldn't probably suggest that.
Yeah.
But you also 3D printed brackets.
Yeah.
And I know you like 3D printing because you and I have talked about this in the past. Like, I can't use my 3D printer, and at one time yours caught fire.
Twice.
Well, and then you brought it over and you let me watch it catch fire. That was totally fun.
Yeah. I've gone through 2 printers that have caught on fire in varying degrees.
And did that teach you not to let them run when you're not home?
Yes.
Which
limits the,
it really does limit
size.
the usefulness of 3D printers because they take forever.
Yeah, some of these things, you need to let it run for 16 hours. And
what you need to do is put them in a metal box with a fire extinguisher system on top. It'll just put itself out.
Yeah.
You have those battery charging bags that are made of flame-proof.
They're just storage bags, not for charging,
I
but
see.
yeah. Put the scary lipos in those.
Do you have the best home shop, or are you going out to community college or library, or where are you getting access to all of your toys?
Yeah, I love having the tools nearby as much as possible, but the laser cutter is not something that I've ponied up for yet. Especially the ones that can cut, 1/2 inch and things like that.
That's serious business.
Yeah. So there's a local makerspace, Idea Fab Labs in Santa Cruz. They have a Chico in Santa Cruz locations, and they have a membership that gets you access to laser cutters and wood shops and all that kind of stuff. I've got, I've got a garage I've dedicated, I've repurposed for all this stuff, plus an office in the house. So my hobby is serious enough that it's taking over some very large percentage of my house.
Which is good if you're running a business, but at some point as you're packing boards to ship on the kitchen table, you start wondering when you get your life back.
Yes.
And maybe your family wonders that too. Okay, so, and then the lights shine into the edges of the acrylic, and you can see the glow of the colors on the etched part of the petals as well as the edge of the petals, but not in the petals themselves.
Through the magic of total internal reflection.
Yes.
Sorry.
Well, I mean, it's. I was going to say something about fiber optics, but that's fine.
Same thing.
You're totally
exactly the same.
You're way out. And it glows, and it can change, and it can change over a long period. So it's not just that it's blinking lights all the time. It's like, oh, it's morning. It can go on gently. It was really pretty.
Thank you. Yeah, and this is it's in my daughter's room as a nightlight, and so I can connect into it. And I've actually put in some patterns. This is where those APA and the global brightness really comes in handy, because I can dim this thing down just to ridiculously low levels, and it's still doing cool, interesting, tones and colors and things. But it's not, obviously keeping the baby up.
Cool. This isn't your first foray into light things. When I first met you, you told me about Cynthia, which is synthesizer and light, and you described it all to me, and I don't think you had any pictures, and I walked away thinking I have no idea what he's talking about.
We can repeat that experience.
Yes, let's repeat that for everybody. That's not, I mean, Christopher's seen it, so Christopher can describe it at least.
I'm trying to remember. So it was a keyboard, and I think there was plexiglass keys or something, but it was all very clear. And as you played, it would like shoot the sound up the LEDs at the same time. So depending on the timbre of the sound you were playing, it would do different things. And as you played, it would be like a cascading waterfall of light. And I'm remembering based on 5 minutes of playing with it. So
yeah, that's pretty good.
Okay.
I like the cascading.
I like waterfall of lights. Yeah.
And that was fun. So Cynthia is in our project I've been doing for a number of years, and she started off just as like if you can imagine 8 clear arcade buttons with NeoPixel LEDs like shoved in them, and it was actually the first one was quite large, 2 meters long of LED strips. And it was kind of like a Guitar Hero thing where you'd press a bunch of buttons, and then a reverse Guitar Hero where you press a bunch of buttons and then light beams would like shoot across to the other side. And there was 2 players, so you'd have another person on the other side and they'd shoot them back and forth. But the whole idea with this thing was an interactive light project, but it needed sound. It just needed sound. And so I was trying to think, how can I make this fun interactive thing that does a bunch of sound that isn't going to just sound like this random cacophony of stuff, right? Well, of course, the music. But then, there's a lot of people that are not musically inclined, myself included, that couldn't just go up to a piano and start playing something that sounded interesting or cool. So it got me to thinking, like, how can I make this thing more approachable?
Right, that was the piece that I forgot.
This was the thing that I really didn't understand. Okay.
So I taught myself enough music theory to figure out why just pressing random white and black keys on the keyboard just sounds terrible. And basically learned about music scales. And so I put into this keyboard the concept of calculating all these music scales for you. So the idea is, you can pick a bunch of different music scales, and you can pick a starting offset, and it'll just calculate the whole music scale for you across all of its keys. And it's kind of fun because you can move one dial to shift up and down the, sort of the starting color. And it's basically, this keyboard is like a rainbow moving back and forth. And another one where you can change the music scale, and you can see, you have some colors disappear and other colors appear. So it's pretty cool because, at least for me, I can intuitively see what's going on. Like, I know that, red is a C. And it doesn't matter, where on this thing it is, all the C's are always red. And so I can pick them out in any octave.
It's like synesthesia.
Yeah, exactly.
It's like it's like a product that causes.
It doesn't cause it; it creates it.
Oh yeah, those are totally different things.
Well, if it caused it, once you've used it, you'd have it forever, and that would be bad.
Well, I wonder.
Or good. I don't know.
I wonder if you could learn
it's not
perfect
LSD.
pitch this way.
I don't think you can learn perfect pitch.
You can
that way.
There are lots of studies that show you can learn
good
perfect
relative pitch.
Even learn perfect. It just requires a lot of effort.
Yeah, but like an oscillator, I imagine that you have some drift depending on what temperature your brain's at.
Yeah,
but that's not a kit yet either.
No, that one is the least manufacturable thing I've ever created. It took me weeks to put that thing together. A lot of little tiny wires, a lot of troubleshooting, and this is where the sort of my adventure into something that isn't a WS2812 began, because I've had to replace all the LEDs on that thing at least 3 or 4 times.
You took it to the Santa Cruz Mini Maker Fair.
Yes.
How did that go?
It was really good. It got a lot of attention. We were kind of back in the corner, so we didn't get a lot of foot traffic, but everybody that came through that area was like just drawn to this thing. It was awesome. And kids,
because it was glowy, and because no matter what you did, it didn't sound awful.
Yeah, it was a lot of fun.
But you had to be inside because it was glowy, and everybody else was outside.
Mm-hmm.
Do you have plans for a future one of those, or future showings of that?
Yeah, I've been working on ideas for version 3, and mainly around the keyboard. So version 1 was just arcade buttons. Version 2 was a little bit more keyboard-like, but it's very wavy. And the keys were not all the same size, and they were definitely not standard, keyboard size. So I'm thinking of shifting a little bit and going a little bit more, as close to piano keys as I can, so that if somebody is familiar with that spacing, they can intuitively play it instead of having to kind of hunt and peck. And I'm thinking about building capacitive-based keys. So right now it's all very mechanical, and you get a lot of clickety-clackety kind of thing. And so I'm thinking, capacitive. I figured out a way to basically laminate the backside of an acrylic key with a conductive layer that's nice and shiny and reflective, and then attach electrodes. And I haven't dialed in yet. I want to make basically, how quickly you end up touching the touch keypad create acceleration for generating different key sounds.
Yeah, that's in the good electric pianos. That's an important feature.
Yeah. What's that called?
Velocity sensitivity.
Yes, velocity. You
have so many interests here.
Yes.
It must be very hard to complete anything.
As at the top of the show, we did ask the question.
Yeah, I might have to change the ratio to maybe 24-1.
But these things we're talking about, you have completed. I mean, I imagine Cynthia is something that you never finish. You just always keep tweaking.
Yeah. Like somebody's hobby classic car, there's always more tinkering to be done.
How did you learn to do all the electronics part?
Oh gosh. Well, I've been interested in this stuff for forever. I mean, I can remember when I was a kid, my parents got me these Radio Shack kits, the 4-bit microcontroller included, but also, like those 101s, 201s, or whatever, the little springboard things. Yes. You'd plug in a bunch of wires to a bunch of, ICs and just bare transistors. And I love those things. Just played with those, tons. When I was 14, actually, my parents got me this mail-in electronic course, an actual college level, McGraw-Hill, mail-in kind of thing, and they'd send me all these kits and books and all that kind of stuff. And I got maybe 2/3 of the way through it. I didn't end up doing a lot of the labs, but I read about 2/3 of the the theoretical stuff. So it was pretty cool. I got a basic understanding of oh, how does a transistor work? Okay, well, there's, silicon, and we dope it, and there's holes and electrons and, barriers and all kinds of fun stuff. So that was cool. But I never really pursued that as a career. I ended up, getting swooped up in the whole, internet thing.
Scooped up into the internet. So you went into software because it seemed lucrative and fun and expanding?
Yeah, I mean, I have, as much interest in that kind of stuff, I would say, as I do in the electronic stuff. So like I find, trying to figure out how to scale big giant clusters of servers and, designing architectures with all kinds of complicated bits, just as fun as I do as tinkering on some little, microcontroller board. But yeah, I mean, that ended up being, my career path. But at a certain point, I did a lot of really great fun things, and I felt like it was time for a change.
And here you are.
Yeah.
Selling things on Tindie. All right. Do you have any advice for people who are thinking about changing careers or are thinking about trying something completely new? It sounds like it's been a good idea for you, but it also sounds like you're not making money yet.
Yeah. And my advice would be, if you can do it. Like always. Okay. If you're interested in something, do it. Like life is short. Pursue all of your interests simultaneously if possible.
Sleep is for the weak. And Christopher, do you have any other questions, or are we out of time?
Oh, right. I'm supposed to answer that verbally.
Shaking your head doesn't do them a lot of good.
No. I don't have anything else.
All right, Ben, is there anything you'd like to leave us with?
I would say enjoy the gifts that are given to you fully and share as you can, and share the things that you learn with other people.
Our guest has been Ben Hencke, the ElectroMage and maker of the Pixelblaze, which you can find on Tindie. There is a coupon, Embedded FM, all one word, all capitalized, and that will get you 25% off of the Pixelblaze, which you can then use to build lights or things. Thank you for being with us, Ben.
Thank you for having me.
Thank you to Christopher for producing and co-hosting. And of course, thank you for listening. Those of you who are patrons?
Patrons.
Those people who are supporting us on that site, I want to give you a special thank you. We did sponsor part of the Open Source Hardware Summit, and I got to give out little tiny stickers to everyone, one of which ended up on our Sworn Enemies t-shirt. Thank you for that.
On the back.
On the back.
Without his knowledge. That's the important part.
Oh, yes. So
I have no idea how that happened.
Now a quote to leave you with. This from a fairly new author, Rita Shiano, and she has to say this. Talking about our problems is our greatest addiction. Break the habit. Talk about your joys. Embedded is an independently produced radio show that focuses on the many aspects of engineering. It is a production of Logical Elegance, an embedded software consulting company in California. If there are advertisements in the show, we did not put them there and do not receive money from them. At this time, our sponsors are Logical Elegance and listeners like you.